Yeah, that makes sense. Yeah.
So currently I'm doing a PhD at the Novo Nordisk Foundation Center for Protein Research, which is in the scope of the Copenhagen Bioscience PhD program. And I attended 2 Choral Cons before and helped a bit on the Datenguide Python project, which you can use to query statistics from public German statistics agencies via Python interactively. And the Matplotlib workshop idea is roughly 1 year old, and I'm happy that we can realize it today. So I prepared the slides for a course at the Center for Health and Medical Sciences, where the CPR, NFF CPR is located physically. This will go this year to the second round, and it's called Python Tsunami, a 3-day workshop, 3 days workshop to get like from bachelor to junior professors. People started on data science and analytics, and this Matplotlib tutorial is one part of it. Normally we would have a bit more time than what we planned today for this workshop, so I think that I will rather go through the slides part of it and leave the exercises open. So don't give you time now for it, because I hope that it should be self-explanatory and you will have, if you're interested, and just have time to play around later with it. But I mean, this is basically a workshop. Maybe the examples are rather for the scientific community, and it's focused on research and publications, and instead, for websites or articles. And the main goal is to be able to give you the possibility to create plots if your data changes, and you don't have to go back to Adobe Illustrator all the time and refresh what you have done before. You can follow the slides, the notebook in Colab. I posted a link. It's also here. If you're on the GitHub repository, you will also find a direct link to go to execute it in Colab. If you want to be sure to have it, please save a copy in Drive or download it to your local computer, because I'm not sure that this branch on this repository will be there forever. And you have a nice table of contents in Colab to navigate easier between the sections. So my basic idea is to give you a conceptual understanding and not too much which concrete plotting functions exist in the packages. And my hope is that you might forget all the commands, but you will be able to use Matplotlib still easily if you find some hints on Stack Overflow or anywhere else. And I hope that you can use it for your own data and fix your own problems. So that said, I have a first list in this notebook on some references. There's a nice cheat sheet, GitHub repository. There's an introduction, again, long video and exercises from SciPy package developers, then from the Matplotlib developers on the SciPy conference. Then there is a concrete tutorial on the Matplotlib website, which is based usage guide, called usage guide, and we have the life cycle of a plot tutorial. And these 2 former ones are part of all the Matplotlib tutorials, and these I selected basically mainly to create the slides. So the objectives are, I want to give you, most of the times, most confusions arises from people not knowing that Matplotlib has 2 APIs, one which is PyPlot and was orientated to be Matplotlib-like, and the other one is the object-oriented API interface, sometimes also called object-oriented Matplotlib. For the Colab link is just above in the chat, but I can reshare it for newcomer. Then the distinctions between what is a figure, what is an axis, and what is an axis. What are labels, ticks, legends, annotations? We just go over it briefly because it's more oriented to the scientific community. Then we will we look at the use case where we want to combine Matplotlib and Seaborn and Pandas, which also have a basically interface to use Matplotlib. And yeah, I hope that in the end, the confusion looking on Stack Overflow and seeing two different APIs all the time will be gone. Okay, so Matplotlib itself is basically a versatile set of instructions for plotting figures. It's used widely in third-party libraries as in Pandas and Seaborn. And depending on your machine and application or operating system, Matplotlib is really the set of instructions forwarding it to the concrete backend program, plotting in the end. And here in my notebook, I'm currently using PyLab backend line. I mean, I don't know much more about it, but if you see differences from arising from the same code, it's probably due to different backends or different runtime configurations. Which leads us already to the definition. So below, I posted a small figure I found on Stack Overflow, I think, and it's from the official documentation. So the figure is basically in common language, probably what you would understand as the plot. And in Python, it's basically the object holding several figures or plots. In this case, one axis object. And the axis object is where the plotting actually happens on. So this will be called to actually plot some data. And unfortunately, in this programming interface naming scheme, axes is the plural of x-axis and y-axis, which are again distinct objects of an axis object. So just as they said, we will see the examples in a short moment. It's a bit confusing. You can also check the pronunciation if I did it right or wrong, but yeah, I sometimes also have to look it up as a non-native English speaker. And please, if you have questions in between, write to the chat or just interrupt me if you dare to speak publicly. The Matplotlib API is once, as I said, the PyPlot global functionality, which is oriented at MATLAB plotting functionality where it originated from. I will never correct this otherwise later. But the recommendation from this user's guide tutorial is actually to use the object-oriented plotting, and maybe we can see why, or you can discuss maybe openly why in the end. But it's open, so there are two interfaces. And we will only look at how to invoke this now quickly. So the PyPlot API would be to use matplotlib.pyplot as PLT. And from there, you can get a figure object using PLT and also just call PLT to functionality to get a subplot, which can be thought of as a utility functions available. Yeah, it's always applied to the current figure and axis. That's basically what you just need to know. So it will be in this, if you know matplot, it will be linear. So if you start in the beginning and you execute commands, the order will be important. The object-oriented API would be to just use Matplotlib, then go to the library figure and get an instance of this figure object and attach then or call a method on this figure instance object to get an axis object, and then you can look at the figure, which now has an axis, and it's an empty one. We haven't drawn anything on it. So this is the second object-oriented one. But most of the times, people and I mix it up. So I use functionality, utility functionality from the pyplot interface, which is subplots, to get a figure in an axis to here in this case empty. Yeah. Yeah. And these utility functions are nice, and you can do many things with it, as we will see in a bit.
And if I use this subplots, it's like the axis. Are there multiple axis things in the
You can get
AX?
multiple axis things. I later have the described interface of subplots or the function annotation.
Okay, but right now it would only be one, so it would be one figure.
If you don't specify arguments, this gives you one figure with one axis.
Okay, good.
Axis.
Whatever, AX something.
Yeah, I mean, most of the times you don't use a Y or Z axis directly with yourself. So most of the time, it's figures or axes. Okay. So if you then have now one figure with one axis, you can look at one of the code examples on Matplotlib, which is kind of a reference and a sneak peek what kind of attributes a figure with one axis has. So figure the whole thing, and if you're now into scientific computing, you can identify several attributes of this plot. And in order to explore what is what, I copied the example and made it object oriented entirely. I mean, it was mainly. So when you get your figure and your axes, and then you call different method calls on this axis. I mean, an axis has already an x-axis, as you can see here, and this one knows how to plot ticks. And if you then are interested what changes, you can just comment out certain lines and re-evaluate the figure, and then you see that the legend goes missing at some point. Yeah, so feel free to play around with it and maybe just remember it as a reference to see what is what and get orientation from there. But I want to go also to answer this question and elaborated example, very easy still, where we now will use libraries using Matplotlib, because Seaborn and pandas plotting use in the backend in there. Use as a package to plot Matplotlib. And I would say that if you're working on your data and it's already in a pandas data frame, you will hardly need to actually use Matplotlib a lot yourself, or the functions plotting from there, but rather the interfaces provided by pandas and Seaborn. Okay, that's what this means. I mean, just the packages. So I have an example which I just had, which is presenting some counts. You can look at the features, but they're not so important. Just notice that the X range basically is from 0 to 10, and then there are several counts associated to these numbers. This comes from analyzing some FASTA files, and I made this. I reduced the dimensions, the total count of these numbers, and just made it up so it fits nicely on the next plots. But that's the data we are operating. We have 3 features, and they all have some values associated to the same x-axis. Okay, so let's plot 4 figures. And now we use subplots, which has an argument and rows. And we can also look at it. You can specify how many rows and columns you want to have, how many objects in between. And the overall figure size is a bit hidden in the keyword arguments, but we will have a look later at this. So this is our figure with 4 axes objects, and the axes now is a list of lists. of shape 2 times 2. Okay. Now we first want to use the data to plot a bar plot using Matplotlib axes API. So we get the x-axis, then the y-axis, and then we just plot. We just select the axes we're interested in, the first one, 0, 0 is in the left upper corner, and then just plot it. The bar plot by invoking the method on this axis object, which knows how to plot a bar plot. And yeah, that's it. It's 0 counts for 0, and 10 has 32, and that's it. You get it. Now we want to do the same with pandas. Therefore, we just create from this dictionary object a data frame where you have the index from 0 to 10, so the x-axis, and then 3 feature columns. Then there's this utility function in pandas on the data frame itself, which or method, which where you can select all kinds of bars, all kinds of plots. In this case, we use a bar plot, and if you scroll through the documentation, you just get a list of what kind of plots are there, and you could play around with this yourself and see what comes out. I'll read the documentation, but basically you can also find the equivalent plot in Matplotlib. And to illustrate also that you could use pandas data frames directly with Matplotlib, we try to plot the first plot we've seen now with Matplotlib, where we use an x, the x-axis data, then and bar plot needs a height, so which is the y, so the feature data. We take the protein ID here and use the a bit bigger, sorry. And the data of parameter you can specify is then the data frame, and this will give you the same plot as the first one, where we also only plotted one feature. Sorry, I did not highlight this. Good, and we just clear now this axis again because we already have the same plot in one position. Now we just add a third plot using Seaborn, and again, Seaborn in this object-oriented setting also and has a, and this I didn't also forgot to mention before, is so you have in pandas and Seaborn both arguments, which is called an axis argument, where you can specify where should I draw this plot on, and you draw plots on axes, and you can just specify then which axis you want, and this one would be the bottom right axis object. Yeah, so, and this is basically, I mean, you just need to get a current subplot axis, and then you can pass it on to the method from Seaborn or from pandas you want to use, and it will draw on this object. Yeah.
I have a question. Why do we have to? Is it like a transform? Do we transform the data frame, or what's the .t?
Yeah, it's transposed.
Transposed. Sorry, not transformed. Transposed.
Yes, sorry. Yeah. Otherwise, there would be garbage out in this kind of plot. I mean, we don't discuss the bar plot methods. I actually only want to highlight how to use in one subplot all three libraries in one. And this is basically by passing objects around or references objects, and yeah, you just need to.
Oh, okay, no, that's fine.
That's it.
Yeah.
Okay, sorry. Yeah, good. Yeah. So, and now you could just look at one of these plots and just repeat the exercise to get it in the last empty axis container of the object, which was not used for plotting. Okay, this would be a moment to ask questions if you have some. I don't see you. No. So otherwise, we can already continue to.
Now, let me just ask one quick question. Even if I just want to do like one plot, I would still use the axis. I would still generate like a subplot with just one axis thing inside. So, because this seems like something that is like useful if you do like multiple, but it's still the way to go if I just want to do one plot.
Yeah, I mean,
okay.
If you, and we can go back to.
Because I think that's something that confused me at the beginning. I was like, why do I have to generate something? I just want to have one plot, but it would still be like PLT subplots one, or just without the parentheses, without the arguments. Yeah. Okay, that's.
If you do this, then you don't get then axis is as a type just really the instance itself. So it's actually then an x, only one. And this would be then the empty still axis object where you can draw on if you want to use this Matplotlib interface. And if you use PLT, you could now use PLT, I think bar something, yeah. Bar, yeah. And then you would need to specify the x height. So let's just do this. I have it somewhere here, so it should be all in memory. And oops. Sometimes I get confused with my keyboards. Now I'm on my German keyboard.
Very relatable.
So, and I mean, you would need to invoke it. So you need to do it to get something. And probably if you leave this away, I mean, now we already have this one.
Okay. No, but it's okay if it's just like the workflow. If the workflow is still, we do this, what you showed where we mixed it, the different APIs, if that's still like the workflow that we use for one plot. I just wanted to know because that's, it's like totally different from what you do in R. For example, you always start with one plot, and then if you want to patch them together, you have to do that later on. And here it's like kind of different. Yeah, so, okay. Yeah, thank you. Yeah.
Yes. So, and this is one of the advantages because I got the hint today that there's also a grammar for graphics for Python. So plotline today. And I just had a brief look at it, but I couldn't find the, the interface yet to specify an axis object. So you really combine it with Matplotlib. Also, in the backend, it also uses Matplotlib to provide this R kind of plotting functionality. If you're familiar with this one, but so far I haven't checked out or didn't really figure out how to combine plots. But maybe the logic is in ggplot2 totally different.
Yeah.
Okay. So then we leave this behind. And see, so I was asked in the last time I tried this talk once before, I was just asked to add the hint on saving a plot to this, which is sometimes nice if you haven't used programming too much, then you can just export your figure you created in your notebook or in Colab or wherever you want in different file formats. So I think this won't be now the current figure, but we can skip over it. You can specify where you want to save it, and it will pick up automatically the file format if you specify it in the file name you provide, or otherwise it will default to PNG, I think. Yeah. And just to see which kind of formats your backend provides on your machine, you can invoke another utility function, which just returns you a dictionary with all the possible file formats available on your running machine in your backend. If you want to save it in Colab, you can also directly, you can save it in Colab and then download it manually, or you can mount your drive and then specify the file collation somewhere relative to your drive. And then it's already stored there and ready to be used. Okay, so this was only saving. Then a bit closer look to the subplots utility function. It has how many rows you want to have, how many columns. We've already seen a 2x2 example. You can say that, especially in the scientific context, if you want to, or anytime you want to plot similar things which you actually want to compare directly with each other, then it's useful to share also the x-axis and the y-axis objects of all these 4 subplots. So then somehow the axis objects, if you invoke them in the example above of a legend or legend of a figure or something, you will probably see that the same instance is shared between all 4 axes instances. And so each axis instance has a y and the x-axis, which is the same. Then we have see later example what grid spec means, or basically how to arrange your 4 subplots in the previous example, and how large you want to see your figure. So and that's just really just thinking how big you want to have it in centimeters or whatever the default is. Okay. So just another example where you plot different random number histograms, and yeah, if you do this again, you can change, for example, the color and the basically intensity of this color. And yeah, then these arguments you can, I think, specify 0. Float integers. It's show now, which will basically shift around your subplots. So y space 0 will just avoid the y space between the figures. So let's put a bit, but reduce the distance. We share the axis here, and all these arguments, if you then play around with it, and the left one is you can do should start at 0. The right one should start at 6. This should work. Yeah, okay. You can basically squeeze and extend the size of these plots. Okay, this is not super useful currently. Okay, if you do false here, just to highlight this last thing, then every axis will have its own scale, and here it's 40 is the max, and it's 30, and it's basically not so easy to directly compare it, which is why most of the times sharing, if you plot similar data in the same figure in different axes, then it's better to just share the y and x axis. Okay, or at least the y axis. Good. I think I have an example. Yeah, then just maybe a bit better example on this graphic. So here it's the left, bottom, width, and height of an axis specified as a list of lists, which then gives you the relative sizes on the figure. So they are both up to 0.9 high they are starting at the lower end at 0.08. From the left, the first axis starts at 0.04 on the figure, so relative, and yeah, the next one starts at 0.4. So then this basically is the spectrum. Yeah, so where basically relative to each other these subplots are. You can also just use the dictionary to give the information in on the construction of the subplots, where you say, okay, what is my ratio of these two columns, and this has to grow with the number of specs, the number of subplots you want to have, and these keyword arguments that is then passed, as you could do it on the previous slide, using the parameter values. Sorry. Yeah, I mean, it's similar. You don't call subplots adjust, but you just give a dictionary on your subplots construction method, where you then specify these arguments. And this is a utility function on all of the subplots directly. I don't know how you would do it for now on the axis itself, but probably, I mean, it's on the figure. It has to be on the figure, so yeah, it will work. Good. Just saying that this exists. I should have prepared this example again. Or looked at the notes. Good. But what I actually only want to say is, okay, you have different possibilities to arrange your subplots. You can then also clear the figure and, for example, plot on this one some frequencies, and here use the table from pandas. So you can actually from pandas plot the values corresponding in the data frame on this figure. Good. Any questions on this part? Otherwise, I would briefly talk about reusing code. So how would you write a function which you can repeatedly use? I mean, if you've once done a special plot to your needs in one of your projects, how to best save it to a disk. And as we have seen in Seaborn and Matplotlib, it basically involves specifying the axis parameter in the function signature. And then you will be able just to pass to say, okay, on this function, whatever you do on this axis instance, and you get back whatever you specified. And then there's a tutorial in the coding style part of this usage guide. Here we just have some metrics from model 1 and model 2, precision and recall. And you can then, for example, plot the performance and have somewhere some colors which are name matched or position matched to highlight what you ever want to highlight. So if one model is your reference model or your model of interest, and you compare it to other ones, then you probably have some kind of specified name. This is, I mean, you could customize it a lot more, but I mean, if this is what you most of the times want to use, you could then just pass an access object and then plot this one precision on the right side. And as an exercise, you could try to plot the recall on the left side of this subplot. And you can have some time to look at the example, but yeah, that's it. I mean, that's how you should you can, according to this tutorial and the instructions from the Matplotlib developers, customize your own plotting functions. Okay, so we go rather quickly now to the end. The APA specifications, I just want to briefly have a look at it at this plot. I mean, when I read this the first time, or many first times, it's always not so easy to grasp what happens, but hopefully with the knowledge of, okay, there are two interfaces. If you see an axis plot functions, you already kind of you can orientate yourself what this is and where this comes from, and what that is a method, no function here on an axis. And then you have some examples. You have the parameters, and which are explicitly made available. And then there is the keywords arguments, which is basically shared by all line 2D objects. So 2D printed objects, the options you always have, and you can always specify additionally. There should be somewhere. Oh, I don't see it now. I think it's fixed size is again different one. Oh, these are. Okay, maybe I've mistaken which object is. Well, so as you see, I don't know all the internals about Matplotlib yet, and this is only the start of these explorations. Good, but so there are some position-only arguments, so they can be specified flexibly if there's a list of them, and some arguments are just hidden under keyword arguments. This is what I actually wanted to show here. You see it here as a keyword argument, and somehow figure size is also one of the keyword arguments which you can specify. Also, we didn't find it now in the documentation. I would suggest that with this knowledge, you could check out the galleries and look at different plots you're interested. And I hope that you know that normally if you use the object-oriented version, you either pass an axis to some function from C1 or pandas, or you just call the respective function on the axis object. If you see on Stack Overflow examples from this Matplotlib-like interface, pyplot, normally it's easily translated to axes by just a set or get prefix to the same method name in my experiences. And if you want to continue from here and you don't have your own data you're interested in, I just have a section where I added some COVID-19 data from the Johns Hopkins University, where you can look at day counts of confirmed, recovered, and deaths by these lists. And you can also then make aggregates based on the population of the countries. It's just coming from a repository, some CSV files, which mirror the Johns Hopkins University and put it in this file formats. There's also from the European Center of Disease Prevention Control, if you're more interested in testing numbers, weekly aggregates by country, and also the cases worldwide again to plot. And here you see, I think, the positive test numbers were somewhere. Positive rate, testing rate, and so forth. If you want to somehow aggregate this into some plotting, and otherwise, just an open exercise. If we would be really in the tutorial, then you could look, if you have time, at color maps and site sheets from Matplotlib or pandas to basically get these runtime configurations with different ways to have the same data represented in different colors. And if I would stop here, I think, because then if you continue with the notebook, you can just have a look at the scientific figures, case studies, where you can just see some figures if you're interested in the scientific figures, Plot some calibration curves or plot some error bars, look a bit at Seaborn, yeah, these are error bars, or do a operator receiver curve, receive operator curve with some AUC values. Yeah, so I would conclude with, I think Matplotlib is very versatile. I myself had my difficulties in the beginning, and with the knowledge from today, at least I hope to stress once more that, okay, there's two APIs, this you have to remember. And if you find examples somewhere, just be sure to somehow see, is it a pipeplot functionality I'm using, some kind of utility function, or I'm using a method on an object, so I'm on the object-oriented world. And if I go to pandas or Seaborn, normally I just have to pass an axis to get the plot. If I want to align it and combine it with other ones. Yeah, and as you've seen also in this talk, I mean, sometimes I have to, on a day-to-day basis, look up some technical details, and yeah, sometimes I still run into issues which I not really can explain. Just recently on, for example, scaling the X or Y axis objects, getting this back and transforming them was, I mean, I got it running, but it's just 10 minutes of trying out. Yeah, you can, I would not recommend this notebook as the reference, but I mean, you can use it as a reference to get this idea, and otherwise always look at the documentation, as there are changes from time to time, and this won't be forever the current and latest version. Yeah, and hopefully there are enough examples, and all the examples are properly referenced, so you can also then save the reference itself and not basically the notebook summary of it.
Nice, thank you. I have some questions, but maybe someone else has a question also. I mean, you can also unmute yourself, or you can write in the chat. Otherwise, it's just my personal personal Q&A here. But I will take it. I will take it. So it was quite all right. So I probably have to look at all of that again and a bit more. So the like kind of global options for like the for example, when we talked about like how to distribute the graphs on the figure, there we worked with the PLT, right? So this is something that is from the from the package then, right? Not from, so we don't work on the this one. Okay.
In my head, I summarize it. I mean, pipeplot PLT, or this pipeplot library or module, is giving you a lot of utility functions, and it's always assuming that you're operating on the current figure or axis. And this one operates on the current axis. And I mean, we quickly have to look now at the description. Adjust the subplot layout pattern, it says, of this figure, and the position of the left edge of the subplots as a fraction of the figure width, the position of the right edge.
So it's very, what I take away from that, so I haven't done a lot of Matplotlib, it's very important, the context is very important, right? Which axis is currently like,
which axis is active or you're actively using on, So
and now, if I wanted to use a different axis, I want to do like AX and equal and select a different one of the list. there, right?
Yeah, I'm just.
Yeah, okay, you're doing like a loop, yeah.
So if we have this one, yeah, we see that it's again a list of lists. So it's 2 rows and 2 columns. And I'm really just looping over the rows, and then I loop over each row, the column in these rows, like could be better named. And then I plot on the axis there. Yeah, I select it. I use the Matplotlib for this histogram plot. And this subplots adjust allows you to squeeze certain figures. Yeah.
Okay. Thank you.
Squeeze the figure. I mean, squeeze the subplots where on the left, bottom, and right. Why this is sometimes helpful if you want to add a super title or a bigger title somewhere. You will see that it sometimes overlaps, and then I think this one is useful to adjust it. I think it's yeah.
Okay.
I mean, in a workshop setting, and I find Zoom not super interactive. I mean, you would start working on examples. Hopefully, I mean, most of them will bring their own data, and then how it works. In the
yeah, that's true. Yeah, it was like, well, it was a really good overview, and I hope like everyone else is also a bit more. I have a bit more security now about the different PLTs and X and figs that come up in Stack Overflow. So that's that was really good to know. Yeah. Are there, and I mean, okay, Yusuf had a question to me whether we will have a recording. Yeah, I will have to see that. I recorded it, but yeah, let's see. Maybe I will put it up to YouTube. I will also talk back to Henry about that, and then we can see. But you have already access to the Colab slides. So yeah. Okay. So are there more questions or some comments? Someone else has some experience with Matplotlib that they want to share, or some other plotting, because there's also the Seaborn, which I've seen as well at some point. So yeah. I mean, then if not, then we can. I will send. There is like a feedback survey that I will put into the chat. If you could fill that out, that would be great, because we always have to like justify of course what we do to our to external people that give us money for what we do. I will also send it around to over the Eventbrite thing. And yeah, if you want to if you did not if you're not signed up to our newsletter yet, you can do so. I will also put that into the chat. So that's where you will get like all the updates about those kinds of events if you don't want to just rely on Twitter or on Facebook or wherever you saw that event. Yeah.
Yeah.
So,
and we would also be just interested in general feedback on this is oriented partly to people who already are or coming from other languages and just go work with Python and the ecosystems there, but it's also oriented probably to beginners. So also, I mean, it would be nice to have feedback, good or bad, about if it was too fast, what points I should highlight on, even if it comes to your mind later. Just pass me a word on the Slack channel of Correlate if you want. And I mean, in the end, it should profit. I want to try it out also to give it, pass on the knowledge in this course environments.
Yeah, cool. Yeah, I will. I can give you some feedback later. Yeah. but in general, I took something away from it, and that's always good. Okay, if there are no more questions, Henry, do you have some last words other than that?
No, thanks.
Okay, thanks for coming, everyone.